So currently we are in RStudio, and in an RStudio we are going to perform the two-way analysis of the variance or the two-way ANOVA. We have set our working directory, and in our working directory we have one dataset mouse_data.csv, and on this dataset we are going to apply the two-way ANOVA. So let's load that dataset. We hope so that this will be pretty easy for you to load that dataset using the read.csv function, because this file is in CSV format. After writing that piece of code, let's come out of the parentheses and let's hit the run button or press the Ctrl-Enter key. And once you will do that, then look at the environment tab. In the environment tab, you can see that the data is successfully loaded. There are total 18 observations and the 4 variables. The 4 variables means that it's the 4 columns, and the 80 observation means that there are the 18 rows. Let's click on this one to view the data. Now, if you will look at the data, then you can see that there are the two different factors that are utilized in this study. The one is a diet, another one is an exercise. There are the different level of the diets that has been provided to the mouse to gain the weight. The low-fat diet, the high-fat diet, and the standard diet. And similarly, the different levels of the exercises are used to observe the body weight gain in the mouse. These levels include the regular exercise, no exercise, and etc. So this is our data. And if you look at it here and the shape of the data, then you will observe that this is actually the longer format. This is not in a wider format. So if your data is in a wider format, so this is pretty good to convert it into the longer format. Otherwise, you will end up with an error. Now, after loading this data, let's come back to the coding space. And now let's check the structure of the data by using the str function. When you will run this piece of code, then look at the console. In the console, you are going to have an output. In the output, you are going to see that the name of the 4 columns. The first column name is mouse ID. The second column or the variable name is diet. The third column or the variable name is exercise. And the fourth one is body weight. We know it very well that the diet and the exercise column values should be treated as a factors, not as a characters. This is actually a mistake that the R has committed during reading the data. So we have to rectify this mistake. Now we are going to ask you a question that how you can rectify that mistake. We have already demonstrated it to you in case of a one-way ANOVA that how you can rectify that mistake. And we are going to repeat the similar process. So what we are going to do, we are going to write down the name of the variable that is holding the data. And after writing down the name of the variable, we will give the $sign. And then we are going to write down the name of the column or the variable in which we are interested to rectify the mistake. After this, we will write down the sign of equality in R, and then we will write down as.factor. So by typing the as.factor, we are requesting the R to consider the values in a diet column as a factor, not as a character. After typing as.factor, we will give the parentheses and we will write down the name of the variable once again. And after it, we will write down the $sign, and then we will write down the name of the column. Let's run this piece of code. Look at the console. We didn't get any error message. And if we didn't get any error message, it means that our code is successfully executed. Now let's repeat this process for the second column or variable as well, which is an exercise. After typing this piece of code, let's run it. And when you will run it, then look at the console. We didn't get any error message. It means that the code is successfully executed. Now after this, let's check the structure of this dataset by typing the str once again. Now look at the console. If you look at the console, then you are going to find it out that the R has rectified its mistake. Now the diet and the exercise column values are treated as a factor, not as a character. Great. Now we are ready to apply the two-way ANOVA on our data. To apply the two-way ANOVA, let's call the BSD library first. To call the BSD library, we will type the library and then we will write down the BSDA. Let's run this piece of code to call that library. The library is called and its functions are now available. After this, let's create a variable named test to store the values of the two-way ANOVA and write down AOV. After this, give the parentheses. After giving the parentheses, now let's write down the name of the column that is holding the numeric values. Now, if you will look at the output of the str code, then you are going to find it out that it's basically the body underscore weight column that is going to have the numeric values. So we will write down the name of this column first. After writing down the name of this column, we will give the tilted sign. Now, after giving the tilted sign, we will write down the name of the column that will have our factor names. The first column is diet. After typing the diet, we will give the asterisk sign. After typing the asterisk, we will write down the name of the second column that will have our factor 2, which is exercise. After typing the name of the column, give a comma. And now let's type the data argument and then give a sign of equality and write down the name of the variable which is holding our data, which is sample underscore data. After typing this very simple piece of the code, let's run it. And when you will run it, then look at the console. No error message has appeared. It means that the code is successfully executed. And also look at the environment tab. You are going to find out that the test variable is created with a list of 13. Great. Now this is time to print out the summary of the two-way ANOVA analysis. To print out the summary, we are going to use a summary function, and then within a summary function, we are going to write down the name of the variable that will have our test results and which is test. After typing the test within the parentheses, let's run it. And when you will run it, then look at the console. In the console, you are going to have your results. Now, in the results, you are going to find it out the degree of freedom, sum of squares, mean squares, F value, and the P value. Now, either accept or reject the null hypothesis, you are going to use the F value and the P value. Let's focus here on the P values. If you look at it here, the P value that is associated with the diet, that is 3.32 multiplied by 10 raised to power minus 8. This is pretty small. And similarly, the P value that is associated with an exercise is 1.49 multiplied by 10 raised to power minus 6. This is also pretty small. And you can see that along with these P values, the three asterisks are there. What these three asterisks are letting you know. These three asterisks are letting you know that these results are quite significant and your null hypothesis is rejected in this case because these p-values are quite small than 0.001 and close to 0. Now look at the third p-value, which is 0.94. The 0.94 is actually a quite large value. And this large value is basically associated with the combined effect of diet and exercise on the body weight. Now, what this large p-value is letting you know? This large p-value is letting you know that the combined effect of the diet and the exercise on the body weight will not have any impact. In this case, the null hypothesis will be accepted. We hope so that now these points will be clear to you now, and you guys will be quite comfortable to apply the two-way ANOVA by yourself. This is an end of the parametric tests portion. If you guys have any question, any concern, or any query, then please don't hesitate to write to us. We are always here to help you out. We are looking forward for your kind response. Stay with us. In the next part of this course, we are going to talk about the non-parametric test for the hypothesis testing.